Hi there, this is my Milwaukee M18 12mAh lithium-ion battery pack. It is several years old. It has failed to be charged by the Milwaukee charger, and so what I've had to do is open this battery pack up, expose the battery cells, and then I use this ToolKitRC M6DAC balance charger together with the balance cable that I've made in order to charge this battery pack. Over the past 6 months, I've had to do this about 3 times so far to rebalance the cells. That tells me that their internal resistance is very bad. So if I continue to use this pack, I will continue to have to rebalance the cells. So I bought a box of different Samsung lithium-ion cells. I have here the blue ones, which is the INR21700-40T version 5. I also have here the Samsung INR21700-30T, which is for the Milwaukee M18 6mAh battery pack. I also have here the Samsung INR18650-30Q, which are for the Milwaukee M12 battery packs. I also bought this 4-cell battery holders. This one is for the 21700 battery cells. They are internally wired in series. The Milwaukee M18 12mAh battery has a battery pack in 5S3P configuration. That means it has 15 of these cells. I intend to replace all 15 of them. And to do that, I put 6 of the cells into these 4-cell battery holders and then connect them with balance cables and a charging cable to my M6DAC balance charger, which can charge a maximum of 6S battery cells. The reason is that I want to charge these cells fully and then measure their internal resistance so that I can match as closely as possible all the cells with similar or close internal resistance and put them into one battery pack. Join me in this video as I show you how I do this. To begin with, this is a generic 4-cell pack for lithium-ion 21700 battery cells. The wiring for the cell pack is in series, and the battery pack comes terminated with a positive and negative wire pair. I've insulated them with electrical tape because I will not be using them. I've put white electrical tape and labeled each of the contacts. So this is the first negative. This is the Samsung INR21700-40T battery cell version 5. This is the positive contact, and I've marked it with a positive sign so that I don't make a mistake. And there is the negative side, which I've left unmarked, and I've done that for all the 6 battery cells. Take the first battery cell, put the negative side there, that's the positive, and I've labeled that 1S, and there's a wire connecting to this contact. So this is the negative, put that in this way, and this will be the 2S positive, and there's a wire contact running this side, and this will be the 3S positive contact. And then if I turn this battery holder to the underside, there is a cable running from this contact through to this contact, and so insert the 4th battery cell in here with the 4S positive contact here. So that's what it looks like. For the second battery holder, I've labeled them the same. So negative contact, the battery in there, and the 2S will be here. I'll flick them all to the positive sign so I can check simply that I've got them correct. My ToolKitRC M6DAC balance dual battery charger can charge 2 sets of 6S batteries simultaneously. I have made a 6S balance cable which allows me to connect with the negative ground to the left side. If you see the link above, there is a detailed video on a review and use of this balance charger, and there is also another video on how I made this balance cable using JST-XH connectors as well as these blade terminals. I've labeled each of the balance cables with a white electrical tape and a symbol. This black cable is the negative ground, and this negative ground cable needs to connect to this negative contact. The next cable is the yellow 1S cable, and that 1S cable goes here. The next cable is the blue 2S cable. That cable needs to go here to the 2S contact. Next cable is the green 3S cable. That cable needs to go here. Next cable to connect is the yellow 4S cable, and that cable needs to connect to this 4S contact. I will now use a blue cable with blade terminals at two ends so that I can join this second battery pack to the first battery pack, where I join the 4S to the negative contact here. Next cable to connect is the red 5S cable. That goes here on the 1S contact of the second pack. And because there is a bulge here, I will put the bulge that way so that this blade terminal gets to go further in. Like that. The last of the balance cable is the blue 6S cable, and that needs to go to this position, the 2S of the second battery pack. Now I need to connect the charging cable itself. For this cable, there's an XT60 contact at one end and battery locks at the other end, and see the link in the video description, which gives a video of how I made this cable. The positive end needs to go to the 6S position, and the negative battery lock needs to go to the negative terminal here. I need to do a visual inspection that all the contacts are in place and secure. That's good. Now I'm doing this just for myself. I'm not telling anybody else to do it and take any risks. I'm very careful and will monitor the charging process, because mishandling lithium-ion batteries is dangerous. They can explode and start a fire. Now I'll turn the power supply to this balance charger on. You can see it's started, and the voltage reading for cell 1 is 3.448 volts, cell 2 3.443 volts, cell 3 3.432 volts, cell 4 3.441 volts, cell 5 3.436 volts, 3.437 volts, cell 6 3.436 volts. So the voltage of all 6 cells is detected and measured and stable and correct. I have calibrated the voltage meter on this balance charger before using it today. If the contacts to any of the cell are not good, it will show up in errors in one or more of these cell voltages. This channel measures the 6S battery voltage as a total of 20.86 volts. No charging has started yet, therefore there's 0 amps output. I press the scroll wheel once to set the charging parameters. First parameter, lithium ion, is correct. Next, the number of cells is 6S. I can select auto or 1S up to 6S. This is a 6S battery pack. Mode is to charge. I can discharge or store. I will select charge. End voltage, the specifications say that for this battery, the end voltage for charging is 4.2 volts. However, I'm not able to get it past 4.15 volts, so I'll just keep it at 4.15 volts. Lastly, the charge current to use. The specifications again for this battery cell say that the standard charge is 2 amps at 4.2 volts. So I will select 2 amps. So all the charge parameters are good. I'm on channel 1, ready to start. I roll the scroll wheel to the right to get the start button. Click start. And it says channel 1 charged to 24.9 volts. I will accept OK. And it has started charging. Charging voltage is 21.5 volts, 0.51 volts is getting higher. Charge current is 2 amps. It says lithium ion 6S charging, and it shows the charging voltage changing for the 6 cells. Voltage measured. If I scroll right, it now shows the internal resistance of each of the cells. internal resistance measured. This is important because this tells me how to match the cells to a pack with the closest internal resistance. So what I will eventually do is label each of these cells that I charge so they're uniquely identified and I can match them to their internal resistance. The time now is 143 minutes and the charger has finished. The message is charge done, and all the 6 cells are measured as 4.150 volts. Total voltage is 25.18 volts and there's a trickle charge at 0.03 amps. Scroll right. So the internal resistance after full charge has varied slightly. Cell 1 was 17 milliohms at the start. It is now 14 milliohms. Cell 2 was 64 milliohms at the start. It is now 58 milliohms. Cell 3 was 57 milliohms. It's now 58 milliohms. Cell 4 was 58 milliohms. It is still 58 milliohms. Cell 5 was 33 milliohms. It is now 34 milliohms. And lastly, cell 6 was 59 milliohms. It is now 53 milliohms. So that's good. Well, I do hope you found this video useful and interesting. Do hit the like button and subscribe to my channel for more and help the channel grow. Thank you so much.